Welcome to the Fire Protection Engineering Podcast, where we ignite conversation about fire protection engineering, safety, and innovation.
I'm Kelly Kidwell, and this is Ben Casey. We're both passionate fire protection engineers here to bring you the latest trends, in-depth insights, and expert advice from across the industry.
From designing fire safety systems to navigating code compliance to business development, we'll explore how engineering can help save lives and protect property.
Whether you're a seasoned pro or new to the world of fire protection, we'll dive into the critical roles engineers play in safeguarding the built environment.
So grab your helmet, check your smoke detectors, and join us as we spark some fascinating discussions about fire protection engineering.
Let's get started on today's episode of the Fire Protection Engineering Podcast.
Good morning, FPE community. Today is a little different than previous days. We have Dr. Milke here on the line. He's going to talk about history of fire protection. We realize the community has obviously an extensive background, and most of the audience does, so we're going to stick to some sort of hard questions and specific topics around that. But maybe most folks don't know, Dr. Milke was my advisor in college, so this is exciting for me. He was subsequently the chair of the Fire Protection Engineering program at the University of Maryland. And he may speak a little bit about the upcoming changes in the Maryland program, and how it relates to history of fire protection engineering. So Jim, wanna start with an intro and maybe go from there.
Yeah, thanks, Ben. And Kelly, thanks very much for the invitation to be part of this today. So happy to get into a discussion about where our field has come from, basically, and how it's evolved over the years. Yeah, I mean, it's something that just this, the evolution of the field and the history of the field is an area of engineering that I enjoy quite a bit, of just looking at the history of technology and how some product or area has developed. So certainly excited to get into a conversation about how the field has changed over the years, certainly over the time of my career, and can go back earlier than that, I think, into some of the roots of our fire protection engineering profession. So yes, thanks very much. I'm happy to see where you want to take this. So.
Well, we can start at the beginning. In caveman times, they created fire. No, we don't have to go that far back. But yeah, I think what we were discussing before we started recording here and prior was maybe some of the historical reasoning for fire protection. Maybe give a sort of a brief overview of your understanding of where the profession came out of, insurance related or otherwise. Probably be helpful to start there.
Okay, sure. So can take us back to the early 1900s is probably where the story reasonably starts, or late 1800s even, with the country experiencing a lot of significant conflagrations, and virtually every major city in the country had a major fire in it, involving multiple buildings and significant losses, and the like. A lot of the initial focus in the field, as a result, was finding ways to prevent those conflagrations, to limit losses so there are not multiple buildings that get damaged in a particular fire. So that's a lot of where a lot of the field started, and you can look to the late 1800s and the development of a sprinkler system, development of a sprinkler standard, concerns about fire resistance that came about in the early 1900s. The first fire resistance standard, the development of the first fire protection engineering program at the Armor Institute of Technology in Chicago, that was along those lines as well, and evolved in part because of some concerns with electrical fires of electrical origin. that got things rolling, got a lot of interest in fire and fire safety. So the fields kind of starts there. It wasn't until really the middle of the 1900s that our attention really focused in a significant way to life safety related concerns. But so it was all property protection in the beginning, and I would say driven mostly by the insurance industry and by the significant losses that they were incurring because of these major fires that were occurring. So you look at sprinklers, fire detectors, fire resistance, all tied to these significant building fires that were occurring in virtually any occupancy, a lot of industrial, but a lot of residential communities in urban areas and so on as well. So as a starter, how about let's go with that and see where you want to take some of those initial thoughts, and then we can go from there, because otherwise I can have this evolve into the 50-minute lecture that I don't think we want to do here for any of our sake. So.
Yeah, I think that's interesting. It's almost like, well, obviously the research and kind of development end of the profession started first, right? Before you really have the designers and consultants who can then, know when to apply those technologies to buildings and properties and whatnot. Because I think even, if you think about mechanical and electrical building engineers, they kind of didn't really become a thing until much later as well. I mean, in the early 1900s, you didn't have buildings with electricity, you didn't have air conditioning. You just had fireplaces, basically. That was HVAC. So it's kind of interesting how it almost aligns too with these other technologies, and how almost the MEP, consultancy as a profession kind of advanced. But I don't know, as engineers and consultants, fire protection weren't as widely known in the world, in the architecture and engineering world, as HVAC and electrical and plumbing engineers were kind of in the beginning, more in demand, versus fire protection, which kind of was just absorbed by the other disciplines.
Yeah, I think that's fair. I mean, with the development of technology, and we could start out development of just electricity, electric power, as a starting point. These engineering disciplines evolved, and we could say maybe civil engineering starts sooner than that, because of bridge design and those kind of things that go into, I think, the 1800s, if not some of the 1700s in their foundation. But for, like you say, for mechanical engineering, certainly for electrical engineering, fire protection engineering, these engineering disciplines are basically evolving as technology evolves, as we have electrified buildings, as later on in the latter part of the 1900s, the development of the semiconductor changes things incredibly in engineering across virtually all fields of engineering at that point, I think we could say.
So over the years, have you seen the curriculum change based on technology change, or has it to some extent stuck to the basics, of code required protection schemes and systems design concepts? I mean, have you seen it change over the years, or not so much?
Oh, tremendous changes, 100%. As I came in as an undergrad in the 70s, there were an awful lot of our codes and standards and policies for how to design buildings that were very much rules driven, set of requirements. The codes had set of rules. They had tables and schedules for how to do design, whether it was number of exits and how wide exits should be. It was a very much something based on a set of rules that were there. Sprinklers, design of sprinkler systems were all done with a pipe schedule, with a big table. Basically, there were no calculations done of sprinkler systems, or time for a fire detector to respond. Again, all just rule based. And it was actually in those just a few of the classes where we could do some calculations that it got me more interested in our field. Those are the areas that I really enjoyed, being able to do some really basic calculations of how long a post flashover fire will last, to try and estimate how hot a steel beam is going to get in just some really crude analyses. And these are all hand calcs. Keep in mind there were no PCs back in the day. Any calculation had to be really simple to be done. And as a result, the profession did very few of those because there were very few that existed. The books that existed had only a little bit of some snippets and a little glimpse at here's some of the calculations that could be done if we take advantage of some of the research that was being conducted in the latter part of the century. The field changed tremendously, and as I think as a result, the need for consulting engineers then changed also, because virtually anybody can read a code book and read a table and say, all right, in this table, this pipe needs to be this size, done. And I don't know that you need somebody with an engineering degree, let alone graduate degrees in engineering or anything like that. It needs to be able to read a code book. So it wasn't until the development of some of these methods, these calculation methods, these alternative methods, that the need for fire protection engineers really took off, at least in the design community.
Yeah, I think that's actually a good transition point to kind of our next topic for discussion is, I just kind of think it's interesting how FPE as a field is kind of more developed in certain regions of the country, certain regions that tend to correspond to areas where there's a fire protection engineering degree program, whether it be the DC area with UMD, or up in Boston with WPI, or on the West Coast with the California program out there. I forget which school it's at. San Luis Obispo.
Yeah, Cal Poly at San Luis Obispo.
Okay.
Right.
Yeah. And obviously in California and out west with wildfires, you see a big need there too, from growing need for fire protection. But then you have certain areas in the center of the country, maybe in the South, where there might be fire protection engineers, but certainly a lower concentration of them and maybe less market support for them from, the standpoint of architect firms actually hiring fire protection engineers as a sub to do design work on a project, when they could just be like, oh no, well, our architects will handle life safety, our electrical engineers will do the fire alarm design, etc. So I guess, what would be your insight as to how do we kind of evangelize these areas with fewer fire protection engineers and get, architects and also end user clients to see what the value of fire protection engineering is and why you would want to hire a consultant for your design job?
So really good question, which means I don't have an immediate answer to it. I have to say, yeah. I mean, I think the way to encourage the development of or the need, the request for a fire protection engineer to get involved, is by someone being able to get their foot in the door, by doing a project that demonstrates the value, and what a fire protection engineer can bring to the project. So it may be just having those seeds planted, for a project that to expose an architectural company or a firm to, hey, this is what a fire protection engineer can do, to have an AHJ appreciate, all right, so this is what a fire protection engineer can do. This is not all just smoke and mirrors. There's a technical basis for this. There's confidence behind the calculations that are provided, and here's the net benefit, right, for the architect, for the building owner to appreciate this is what a fire protection engineer can do for me as an owner, that they can allow me to have this particular building that maybe stands off to the left of what a code would require a little bit, or right, or whatever, off to the side, I guess I should say, of what a code could require, and we can accomplish what we want to do, either in terms of some unique design characteristics, unique usage of the building, whatever whatever it might be, and I think a lot of that is needs to be just somewhat organic, of having somebody go in, do a project, demonstrate what's possible outside of these metro areas that you identified that have a strong concentration of FPEs and a lot of activity already by the entire design community, that or from the entire design community that understands, oh, all right, so this is what the fire protection engineer does. And that's on the design side. I mean, on the forensic side, it's a similar sort of issue of having the legal profession understand, oh, okay, so this is what a fire protection engineer can do in a particular forensic case that again occurs through these people getting some experience and some exposure to what an FPE can provide to them.
Yeah, it's an interesting, I didn't think about the forensic side. I mean, the expert witness, the rates that we can command for engineering services on that side of the industry is much higher than on the private design side. So obviously the value has been shown there, maybe better than it has in other ways. I guess two thoughts come to mind. First is that I used to always joke with folks that the best lobbying that fire protection has ever done is putting the program at the University of Maryland within a stone's throw of the DC government, so we're just show up and get involved in the congressional, buildings and facilities, and then all of a sudden fire protection engineers are required in all the federal projects. So yeah, I mean it's being, front of mind, right? And the other one, I don't know if you saw this, I just saw it this morning, the Grenfell fire, there's a Netflix special coming out next month. So just the thought that brings to mind is we have to educate the public that this is still a problem, right? It's something that we solve to a great extent, but if we back off at all, it's going to become a major issue again, all of a sudden. And people don't, they're not exposed to fire every single day. So maybe if you can talk to some of the past events like Grenfell, that have caused major code changes. So perhaps we can all, regroup and start to talk about those things to get FPs in front of owners going forward. Thoughts on, like the Vegas fires and those kind of things?
Yeah, sure. Our field, or maybe the field has certainly responded to a lot of serious fires. A lot of code changes have been enacted as a result of very significant fires that have occurred over the years. So we become somewhat reactionary, and I don't know, maybe that's society in general that's reactionary. It's difficult to get them excited about a potential risk if they can't see what damage can be caused. And that dates back all the way again to those 1800 fires of the conflagrations, and the cities were being built up. And even though there have been some devastating fires here and there, the attention wasn't there until it started happening, and the losses started piling up. We end up with interest in life safety really taking off, and having concerns for interior finish and what we line the walls and the ceilings with a series of hotel fires in 1946 that initiated concerns for, okay, so we have to find ways to regulate interior finish in buildings. So we have that issue that comes up, and it comes up over and over again. The high high rises, high rise fire safety. That you couldn't go to a conference in the 1980s and late 70s without high rise fire safety being on the agenda, and several papers on those. And keep in mind, going back to that era, high rise buildings weren't routinely sprinklered. They didn't routinely have smoke control in them. So they were basically there. They were fire resistive largely, and there was some sense that that's going to be an acceptable design until we start having these multi-fatality fires and in the MGM and DuPont Plaza fires and so on, and here in the U.S. And again, a lot of cities had these major fires in high-rise buildings that occurred with these fire-resistant buildings that were thought to be fireproof in some publications, and yet multi-fatality fires that are occurring. We can go to the station fire in Rhode Island now. 22 years ago, 100 people die, and a lot more attention being paid to place of assembly, where there had been attention paid previously to from Beverly Hills in the 70s, Coconut Grove in the 1940s, are all these significant fires that motivated changes in our codes as we learned about these learned about these catastrophes as they were, but not just learned about them, but we were able to find ways to here's how to prevent this, and in some cases motivating some engineering approaches for how to do better. So I think that ends up being where some changes have occurred, and it was in these from the 40s until the 70s, even 80s, I guess, where our attention turned to life safety as a significant goal. In that, in the late 1800s, as I said, with the conflagrations, we talked about the conflagrations. The concern was, let's try and find ways to limit fires to a single building, and not have multi buildings, affected here. And we get to a point in the 70s and 80s that can we find a way to prevent the fatality in a fire, and start with it in commercial occupancies with that. What can we do in commercial occupancies? What can we do in schools? What can we do in homes? And that motivated development of smoke detectors. I mean, detectors before the 70s were principally there for property protection reasons. It wasn't until the 70s that we said, hey, these could be a life safety device, and oh, by the way, we can put them in a residence. As the technology advanced to be able to have a unit that could be installed in a home. Look to residential sprinklers that have been developed with life safety in mind. Absolutely, life safety in mind. So even the sprinkler technology changed from being a property protection device to something that can be used to assist with life safety in various communities. The whole idea of smoke control. I mean, smoke control was limited to natural venting basically, and up through until the 70s, 80s timeframe. And it was natural venting. There were, by and large, in an industrial type of property, because again, of property losses and some significant fires. And it was, I guess you could point to MGM and the Hilton fire in Las Vegas to say, maybe we ought to think about stair pressurization as an example for smoke control, as a way to limit smoke spread from floor to floor, let alone provide a pathway for people to be able to get out. So yeah, I think there are lots of changes that way, and an awful lot of that, unfortunately, needing a major disaster to motivate the change.
Yeah, I feel like, I don't know, I always feel like in this profession, we're just waiting for the next major disaster to happen and then make changes. Like, I like the whole Grand Challenges initiative that SFPE has to do some research and kind of advance our empirical knowledge about fire and building safety and, just human nature so that we can make these designs better before we do have another tragedy. And I guess, I mean, Ben mentioned Grenfell earlier. I feel like, at least in the US, we have different standards from Europe and the Middle East where they seem to be having a lot of exterior spreading fires right now, because of their building cladding being combustible, the types of materials that would not necessarily be approved for a building in the US. So I was just interested in your thoughts of, I mean, the way that our building codes have evolved in this country, and also how they've, started like this and have since become this thick. Um, if you have any thoughts about how we're a little bit different in the US versus other countries, and what are some advantages to having kind of the model building codes emphasized versus performance building codes, and having, um, fire engineer experts be the one to decide how a building is designed and built from a fire safety standpoint.
So, yeah, there are differences in the U.S. and in practice abroad. I had some exposure to engineering practice outside the U.S., fire protection engineering practice outside the U.S., but not extensive experience there, I have to admit. Here in the U.S. with the model codes, I mean, there are, let me start that again. So with the model codes that developed, and just our process of developing codes, that I believe is more open for public input, and for input from a variety of sectors. Just given that the process that we have with ICC and NFPA and any of the consensus standards that we have, there's opportunity for these more advanced inputs, I think. The enforcement side, though, is probably is just as important, though. And for the enforcement side, with the ecosystem that we have here in the U.S., that there's a strong enforcement presence that we have here as part of our structure, and that's not a given outside the U.S. I hear of story. We don't need to name names, perhaps, but there are some other countries where we're having a building official actually review plans, let alone inspect the design, is not common practice.
That's wild to me.
Well, yeah. I think there's pockets of the U.S. that are like that as well, and that might answer some of what we were talking about earlier, is why certain areas haven't really adopted fire protection engineering.
Right.
So yeah, it's a good point.
Absolutely. Yeah. So, or just that, that some parts of the world don't require PE to do a design of a structure, let alone design of a fire protection system. So it's there's a very different ecosystem that's present, or the lack thereof, I guess, in some other areas of the world where we've got a fairly strong, in at least the metro areas, and a lot of the metro areas, there's a pretty good ecosystem in place. That now could it be better? Absolutely, right. Can we have a more educated design community? And to fire protection engineers have addressed that to some point, of having now degreed fire protection engineers, fire protection engineering technology. That's an educational background, so I don't want to get into any discussions about engineering versus engineering technology programs. Having an educated workforce with whatever label of degree is important. On the regulator side, are there certifications in place for the regulators? Are there educational requirements as opposed to someone that's been an electrician all their life, so they're going to be an electrical inspector now. And with due respect to that person with a lot of practical experience, they may not have the training to deal with more sophisticated designs, more sophisticated systems. And I think it's that's an important area that we still have work to do, and to provide an educated workforce in whatever part of the ecosystem it gets involved in the design.
Yeah, it's, I guess that's the real question is where do we go from here, right? With what's happened to date. And that's really you know, history needs to inform the decisions we make going forward. So I guess I I was asked to bring up the topic by other folks when they heard I was speaking to you this morning about it. Most clients tend to bring us in with the intent of skirting codes and standards. I mean, honestly, that's a lot of the driver. And so, we come in to present to them on engineering judgments and equivalency analyses, and we stick to finding an equivalent level of safety by working around some of the prescriptive requirements. Um, but really what's driving it is a lot of trying to reduce costs and thinking that removing requirements that are codes and standards is the way to do that. Um, and I think that the reason it was interesting for you to weigh in on it is we don't often hear from the academic side on how to address that. And I think to what you said earlier, it's an education thing, right? So maybe coming at the program of the future in fire protection, do you see more of the course material being provided to other disciplines, perhaps? Or is that a way you're looking at potentially expanding the program? Or what do you see coming down the pike?
I, yeah, having the other disciplines at least be aware of what a fire protection engineer can do, and understanding the technologies and so on is important. There that a lot of the original motivation for our online grad program that we launched 20 some years ago now was to provide an educational background for those people who had gotten themselves in fire protection through just some general evolution. They're mechanical engineers, they're maybe civil engineers, and they had a fire project somewhere along the way. And as they did that fire project, well, they get another, and then they get another, and so on. So they've been doing some fire protection engineering without a strong background, and maybe doing okay, but maybe wanting to have a little more confidence in their abilities and be better grounded in the field. So that was a lot of the original motivation for us, was to provide that educational background for us at the University of Maryland, to provide an opportunity for these people that had gotten involved in fire, or maybe wanted to get involved in fire, to take a course, or maybe do a set of courses, do a whole degree program perhaps, that would provide that educational background for them. So this is something that I see happening, and morphing into undergrad programs as well, and for ourselves, and looking to launch online delivery of our undergrad classes, again, for somebody that wants to pick up a class, or a whole degree, perhaps anywhere in between. EKU, Eastern Kentucky, and Oklahoma State have gone online as well, with trying to expand the people that can take their degree program, so somebody doesn't have to move to wherever that university is located and stay there for anywhere from 2 to whatever number of years it takes to get a degree. And they can now take advantage of these degree programs as educational training that can help provide that better background that, such as we've been talking, is needed, if we're going to have a strong set of people involved in the design, or on the regulator side, either group.
And is that, are is the plan to offer the full program online, or is it just individual courses? I just having a hybrid like that is interesting to me. I've been involved in kind of both, including my master's was virtual for most of the time, but we would come into the class. So how is that kind of working?
Right. I mean, for us, we'll offer the fire protection engineering courses online.
Okay.
So that means for somebody who wants to get a fire protection engineering degree, if they've not done any college work at all, and they now found out about fire protection engineering somehow, and they live wherever outside of Maryland, and say, "Oh, I'll do this online degree program." That means they've got to take all the beginning courses somewhere else. Maryland does not offer, at least at this point. Who knows what the future holds? But at least at this point, the basic engineering courses, calculus one, physics
Okay.
one,
Right.
those
Right. Okay.
they're going to have to get that somewhere else. Be it another school, growing number of schools are offering those courses online, or they'll get those things at a local four-year school, local community college, to take care of a lot of that coursework.
Yeah, I feel like most community colleges have that, and maybe not up to like the advanced physics or thermodynamics, but they definitely will have the math and the gen ed credits, like the English and
Right.
whatever other gen eds you need. But I don't
Right.
know. I've worked with a few people who have, majored in something else, physics or some other type of engineering, and then gone on to become a fire protection engineer and enroll in the online master's program. So it's great to hear that there's going to be an option for students who, don't have an engineering or a STEM degree yet and want to do fire protection, because there's certainly a need. Like, I don't know, there's kind of chatter. I feel like people saying, oh, college isn't worth it anymore. But, young people and parents of them, whenever I come across them, I say, you know what? Fire protection engineering is going to be hiring college graduates for a long, long time. So if if your kid's about to enter college, like, you can't go wrong with fire protection.
Right. Right.
Yeah.
I mean, yeah.
100% job
Yeah.
placement.
Yes, absolutely. And it's not a question of will I get a job. Engineering in general is strong in terms of job placement, but fire protection engineering is strongest, at least as I see the surveys from the other departments at Maryland, where they have good job placement, but not 100%. And any graduate is going to have a choice of where they want to go. So it's not will I get a job, but which one will I choose, becomes then the challenge for the student to try and understand. But this is all, again, because of as we talked in the beginning of this, because there's this drive for fire protection engineering talents in design and forensic applications, principally or major drivers of the new placements in the field, and that's not going away anytime soon. Given the supply demand ratio is way out of whack, and as you and you two may be looking for new hires. I see on LinkedIn, a lot of companies advertising for fire protection engineers and such, and just it's difficult to find fire protection engineers who are not already employed, and such, sort of short of going to another company's staff and recruiting from some other company, right? So
Yeah.
yeah.
Yeah, I've worked at so many companies where you almost have to convince HR, like, no, like, really, I know everyone says they're different, but fire protection engineers are really different. Like, we need to just constantly have a job listing up so that when someone gets dissatisfied and goes to look, that we're an option to them. Like, you
Yeah.
need to just be up there all the time, or else you're going to miss, that whatever 1 month window when an FPE is actually looking for a new position. And if you don't have a job posting up, they're not going to see it. They're not going to consider you. It really is different, even compared to like mechanical and electrical engineering. Like, it's a full-on battle for talent in fire protection.
No, absolutely, and that's I mean, I've told many students or alumni who I've reached out to, and they're grumbling a little bit about their job or whatever. I said, in our field, you never have to be unhappy because there are lots of other opportunities out there. If you don't like what you're doing now, there are other opportunities. The other thing I think that distinguishes us from what I hear, and maybe I hear selectively just some anecdotes, but the fire protection engineer, the new graduate, the junior engineer that's a fire protection engineer, they get involved in more exciting projects early on than the beginning civil engineer, the beginning other engineer. They get challenged more, they do more interesting things, and there's less of doing some menial tasks day in, day out. Not that any of us avoid doing menial tasks from time to time. Some of that's needed as part of any job. But there are many more exciting opportunities and just exciting opportunities available for the fire protection engineer, the junior fire protection engineer, that are available. They're not available to the other engineering disciplines. You don't have to wait 20 years in our field and before you get to do the interesting stuff.
Yeah.
So,
And travel, if that's what you want to do, you can definitely do it as a fire protection engineer. Even early on, like I had lots of travel opportunities as a like, an EIT, like not even a full engineer yet.
right.
Well,
Absolutely.
so going with travel, how about this one? If you could travel back in time, let's get back to history
Whoa,
here.
there we go.
Name a few events you would like to have been a part of or seen, or maybe even folks in the profession you would have liked to meet. Or maybe your answer is you just want to go to back to undergrad in University of Maryland and hang out during that time again.
Yeah.
What are your thoughts there?
Oh, geez. Yeah. I mean, certainly, the undergrad days were the good old days for sure. Um, uh, and being involved early on in the field and learning new things and so on, getting involved with new experiences. That's those were all enjoyable, and to be able to do a lot of that. I don't.
So you wouldn't want to go and see if the cow kicked over the lantern for the
Yeah.
Chicago. It's not
Mrs.
like,
O'Leary's cow.
right.
Yeah.
Like,
Right. Yeah. Yeah. I don't know if I want to go that far back with that kind of thing, but I mean, as much as I have those things I would like to have wouldn't mind going back to and revisiting, um, and just the excitement of getting a new experience and getting a new opportunity and so on. I mean, that's part of what I've always enjoyed about our field, and can look at even the experiences I've had recently where I'm involved in learning some new areas and so on. And it's interesting to learn about and get involved in a new part of our field I hadn't spent much time in before. So yeah, I don't know.
what about a
Yeah.
specific time you saw a new technology or something and you remember thinking it was going to be a big deal? Like remember you were involved in the video detection system research and testing. I remember when that first came out. Is there anything like that that you thought when you saw it, like this is going to be a game changer?
Um, I mean, yeah, you bring up the video detection. That's interesting because that was I certainly thought that was gonna hit
Yeah,
more
so
than
did
it
I.
did.
So did I.
Yeah. I just thought there were going to be tremendous applications there, and there are some, but I've not heard that take off as much as it did. I think. Another of the technologies that we had some involvement in at Maryland was the directional sound for as a wayfinding aid for people. I anticipated that was going to go further than it did as well for um, blind people and vision impaired people that can't see exit signs and that sort, that the sounding devices would be an improvement. And I appreciate there were there are challenges with that, and what do you do with the fire alarm system that's going off at the same time you're trying to get people out through these exit signs that are making noise. But I thought that was going to go farther. I guess looking back to World Trade Center and the fireproofing material, or the fire protection material put on the steel, I had the thought that that we were going to go more to materials with stronger adherence properties, more of the intumescent paints, as a result of the problems shown with the spray applied materials that don't adhere very well. And there used to be some tongue-in-cheek comments from some people in the passive fire protection business that I can go into any building I want and I can find missing protection on a steel beam or truss or column in any building anywhere. And just thought, all right, with 9/11, this is going to motivate that change. And it's a much more expensive way to protect steel, but I had the idea that was going to change the field, and it made some change, but not nearly as much as I thought it was going to make. So, and I don't know if that's just the naive academic in me or what that is, but I really thought that was going to go farther. As we look now, I'm really curious as to what's going to happen with AI in our field, and how I mean, AI is part of what we're all dealing with, like it or not, kind of thing.
Yeah, especially in
And
education, right?
Yeah, exactly, exactly. And it's being used some by FPEs, and can it be used for plans review, and all these kind of things? Can we use it for smart buildings? I'm just really intrigued as to where this might take us. So.
Well, I think that's a good one to maybe end on here. I don't know, Kelly, if you have any other thoughts or questions?
No, I'm good.
Jim, anything else you wanted to address? So you
No,
don't know if the cow kicked over the lantern or not, or we're uncertain on Chicago's origin of the fire?
right. Well, yeah, the poor cow has been blamed here, and there was some that say inappropriately so. So I don't know, but no, thanks very much for the opportunity to get together with you today. This has been enjoyable. So.
Yeah, no, great to talk to you. Always great to see you. And we'll connect again soon. Thanks,
Okay.
guys. And that's a wrap on today's episode of the Fire Protection Engineering Podcast.
We hope you found today's discussion as illuminating as a well-designed sprinkler system. That makes no sense. Remember, fire protection engineering is all about making spaces safer for everyone.
If you enjoyed today's episode, be sure to subscribe, rate, and leave a review. And don't forget to share the podcast with anyone you think could benefit from it.
Got questions or topics you'd like us to cover? Drop us a line on social media or through our website. We love hearing from our listeners.
Thanks for tuning in, and remember, safety is no accident. Until next time, stay safe and keep engineering for a safer world.
See you next time on the Fire Protection Engineering Podcast.